So, yes, I had the opportunity to evaluate the eco-friendliness of this particular SCAD URBED Eco Home at Tirunelveli, and it was an enriching experience to say the least. So, I'm a part of the R&D team of this Singapore-based company called Cheese Square, wherein I thought it would be very interesting to give a 2-minute introduction to what I do currently. So, what if we could assess any building anywhere, anytime, instantly at super low cost? Now, this is possible using a technology called digital twins, wherein any existing building can be turned into a 3D model on a map-based platform. And once it's translated into a map-based platform, you could evaluate the savings potential of a particular building by knowing its history. So this is what I am doing at Cheese Square right now, and this platform called Better Life helps churn out green buildings at a faster rate and evaluating them at a really rapid mode. Okay, now having said that, let me get on to the project right away. So very quick snapshot of the building, that the home, the eco-friendly home that we are talking about. Certain things would immediately come into the picture. Number one is, surrounded by trees on various levels. You can see there is a small little leveling that's done before the house is constructed. We'll come to that. And, mainly something that catches your eye immediately is the kind of greenery that's around the building. So very quickly, how did we evaluate how this building actually, how this eco-friendly home actually stands out compared to any other development? So what we did was took the details of the building from the satellite imagery that is available as an open source, and we translated and converted this into a 3D model, or a digital twin as you call it. So a digital twin is a replica of the actual building wherein you could do all your trials and testing. So instead of doing it on the prototype, on the physical prototype, you do all your testing on a 3D virtual clone of the actual building on site. So this is exactly what we have done here. Created the building, simulated it, and plugged in all the available surrounding aspects such as the trees, the shades, etc. And let's see what the results are. So if you take a look at the most important aspects that have gone into the building, there are a lot of efforts taken to reduce the urban heat island effect, which is one of the key cause for issues, especially in the Indian subcontinent, wherein the summer temperatures can be anywhere between 5 degrees to 10 degrees more than the ambient temperature. Now, this is because of rapid concretization, wherein all the concrete surfaces absorb the heat and let it back into the atmosphere, as a byproduct of which we experience really hot waves and issues associated with increased temperature. This includes, people getting strokes, loss of flora and fauna, loss of a lot of native species. So all these issues are there. So these are some of the techniques that were adopted by the home, surrounding by trees, planting a lot of saplings. As you can see, you see a lot of air purifying plants over here, and something very interesting that's catching the eye of a lot of people worldwide: coating the roof with white color reflective surfaces. Now, the easiest way to do this is to paint your roof white. But if you can see what we have done here, we have reclaimed broken china mosaic tiles and laid them on top, because it's the color white that promotes the reflectivity. And as we know, the visual component of sunlight, which can actually, upon hitting surfaces, get converted into absorbable heat, and thereby it's really uncomfortable. So these are certain techniques. In continuation with that, you can also see that we have a 2 kilowatt solar panel which generates a lot of power. And apart from that, you can see the gap, the air gap between the facade and the wall, which further acts as an insulation. Just going forward, now what does this entail? What does this translate into? I'm just gonna see if I can. Okay, so this is a test done on the 8th of May, which is the hottest day for this particular region of Tirunelveli. If there weren't trees around the site, you can see that the site temperature is 42 degrees Celsius. Now, with trees around the site and the cooling impact of the trees, the temperature has dropped by 7 degrees Celsius. So every time there is a wind that blows in this particular region, we can estimate that the air comes in at 35 degrees Celsius and not 42 degrees Celsius. Another very important point, because the site is 7 degrees lesser than ambient, it also attracts winds, which in general okay, flow at a 20-meter plane because of the urban heat island effect alone. So this is one of the direct impacts. Going forward, what we have also done is estimated the air movement through this particular home. As you can see, this is the entrance of the home, and a significant amount of wind comes in from the southwest direction, or rather west of south direction. And if you can see, the openings are in such a way that there are openings on the south direction and in the north direction, promoting significant amount of cross ventilation. So we are in the COVID times right now, and there's a saying that goes this way: flowing water does not breed mosquitoes, and this is very true as far as a green home is also concerned. When you have flowing air through the home, the pathogens will not breed, and there is continuous evacuation of any kind of growth, be it viral, be it bacterial. So it's not only promoting energy efficiency and eco-friendliness, now as a byproduct of which health is also an important factor that's passed on as a benefit to anybody who occupies this home. All right, combined with, so as I told you, the cross ventilation technologies are such a way that you have more than two openings. You have openings in over two facades of the same house, thereby there is continuous evacuation of air. Further, to reduce the temperature, if you can see, the ground gains are significantly high in a place like India, wherein the ground gets heated up, and through the bottom of your, to the underlying surface of your home, this heat gets transferred inside your home. So both the roof treatment and the floor treatment were done, as a byproduct of which additional insulation was ensured. Now, by doing all this, ensuring that the urban heat island effect is minimized, by ensuring there's a lot of cross ventilation, by ensuring there is significant amount of insulation, we took care of all the three formats of heat transfer: convection, conduction, and radiation, and thereby reducing all the three forms of heat. The result is there in front of you. I'll probably start off with the hottest month of the year, when the peak external temperature is 38 degrees. The real field temperature around that area is 42 degrees because of the land absorbing the heat and radiating it back into the atmosphere. However, this particular site had an average temperature of 35 degrees during the peak day, and the temperature internally was 31.85, roughly about 6 degrees, over, let us say, about 7 degrees Celsius lesser than outside. And the number of air changes, this is a significant result that we got because of the cross ventilation. As a byproduct of maintaining cooler indoor environments, we attracted a lot of wind inside the building, and there were about 40 air changes inside this building. The norms as per the National Building Code is about 6 to 8. That makes a home a really healthy home. But then you can imagine what happens with 40 degrees Celsius, and as a byproduct of which, everything adds on together. The temperature is lesser, the people are healthier, and I'm very, very happy to tell you that this home does not have an air conditioning system. It operates passively because this kind of comfort conditions can be met. As you can see, across the year, because of the various wind orientations, the air changes are significantly more at other times of the year. And when we come to the months of January, February, and December, the cooler months, generally the air changes are less, but then the temperature is so comfortable inside, even in a natural way. Going forward, there were so many other aspects. I've just spoken about the health and the thermal comfort aspect of it. If I have to speak about all the other green building aspects that went into the project, 90% of all the material source for this eco home is locally manufactured. Thereby, this project did empower the local manufacturers, the local artisans, the local laborers. So it was not just green from a building point of view, it was also green from how it started enabling the population in and around the project. So that was very interesting part. So it's sustainable in the true sense. Then there was a lot of recycled and reused materials used in the project. As you can see in the picture, all these clay tiles that you're seeing have been salvaged from another site. They were washed, treated, and reused in the project as insulating devices, and thereby you could see the difference. There was a temperature drop of about 6 to 7 degrees in the peak month, and this probably contributed to at least 2 or 3 degrees reduction in temperature. So eco and all the products had a lot of recycled content like fly ash, recycled steel, reclaimed clay tile that you see here, and there is no material that was wasted. For example, even the kitchen and garden reuse, even after the building was constructed, the waste that is generated today is being processed in some very traditional methodologies using these vermicomposting pits that churn out manure every 15 to 20 days. You can see that these are some stone girders that have been reused for support systems within the project. Significant reuse of fly ash bricks that have significant amount of recycled content. These added on to the project's green value or the sustainable value. Now, some very interesting aspects here. This is a rainwater harvesting system, constructed in the traditional methodology. All the taps were fitted with aerators so that the flow rate is restricted to 2 liters per minute, and thereby, compared to a conventional home, this home could save about 50% of water. Not just that, some very smart, innovative methodologies. In India, this is called as Jugaad, or quick fixes, DIY fixes. So what you can see here is a 1 liter bottle filled with water is placed inside the flush system so that 1 liter of water gets displaced, and as a byproduct of which a 4 liters per flush tank has now been converted into a 3 liters per flush tank, thereby saving 1 liter with every flush. So these were also, and you can also see that this is a dual flush system. So you can imagine the savings in water just by doing a very small measure of displacement, the most basic physics that we have learned. So as a byproduct of all this, now this is one building one home wherein the idea wasn't to take a look at the IGBC checklist and start ticking the boxes and start making sure that each and every feature measure mentioned in the standard is implemented. Instead, the approach was very different here. The building was constructed, and because the sustainability practices were in place, we just had to pick up these sustainability practices, and we tabulated, we started evaluating it. And once the marking system came out, it was very straightforward for us. We got a 63 out of 100, thereby achieving the platinum rating. In fact, we also understand from the Green Building Council that this project can also be pursued as a net zero building. The 2 kilowatt solar panel on the rooftop of this particular building caters to 100% of its electricity requirements. Thereby, not just a passive greenhouse, it also is really close to a super low energy building or a net zero energy building. Just a quick snapshot, we've got almost all the points, 9 out of 9 as far as site selection and planning is concerned. All the amenities were really close, stones throw distance away. People need not start their vehicles to procure something. They just have to take a walk within the campus or probably a little outside the campus to meet their ends. Water conservation, except for the treatment part of it, which was really not required for such a small home, we had everything else in place. Energy conservation, we again did not opt for specific things like solar water heater. Instead, we had the solar water panel and materials. You can see we got a huge chunk. Indoor environment quality is probably one of the key aspects of this particular building, scoring a 13 out of 15. And innovation, there was no, we weren't short by any means in terms of innovation, be it the native technology as far as biocomposting is concerned, or the rainwater harvesting system is concerned, or the organic garden that you'd hear about in some time. All these aspects were absolutely in place, as a byproduct of which getting a platinum rating wasn't difficult at all. And this home also got featured as one of the top 50 green rated buildings in the country last year, and it has got featured in the IGBC coffee table book for the country. And as you can see here, we have our platinum certification here, and that's about it.